We have a piecewise function, three domains. Now I'm going to graph basically three different lines, but they're going to kind of be connected. So this is my xy plane, and so anything less than 0 is x squared. Now what does x squared look like as a function? It's a parabola, right? So let's look at it like this. I'm going to say f of x is equal to x squared. And if I were to make a table of values, I've got an x here and then I've got f of x here. So if I define the domain as less than 0, that means all negative numbers, right? So I'm going to plug in a couple of negative numbers. I'm going to plug in -2. I'm going to plug in -1. And then I can't plug in 0. Okay, but what's -2 squared? +4. What's -1 squared? 1. And so if you remember, this kind of looks like it's a parabola that crosses the origin, right? But I'm only going to do it from here to here, and then I can get really close to 0, 0, but I can't plug in 0 because we're not including 0 in our set. Now, for the next function, I'm including 0 and I'm including 1. So I'm going to evaluate x cubed from -1 to, I'm sorry, from 0 to -1. So I've got my x value here and f of x here. So I'm going to go from 0 and 1. Those are the two numbers that I can put in there. Well, what's 0 cubed? 0. What's 1 cubed? 1. Now, does anybody remember what that graph looks like if I were to graph a little one of it? It comes up through here. So it looks like a little snake thing. It's got that little wavy thing. So this is going to come through here, and it's gonna kind of have like this little shape. And then our next function would be 2x minus 1. So I'm going to say 2x minus 1, and again, anything greater than 1. So I have to be careful. If I were to plug in 1, what would that be? 1 times 2, 2 minus 1 is 1. So I'm going to be right here at about 1, 1 is where it starts. But then if I plug in 2, I'm going to get 3. If I plug in 4, I would get 8 minus 1, which is 7. So it's a straight line with a slope of 2. So I'm going to go up 2 over 1. So it's going to kind of look like this. Now if you did this on graph paper, it would look a lot nicer. Okay? But that's sort of the shape it should look like. It's continuous because it's defined at every point. Right? If I plug in 0 here, it's 0, even though I can't count this. So technically there's like an open circle from one function, but it gets closed by the other. Again, here we have an open function, but then it gets closed from the other, so it's like a continuous function. But it's a piecewise function. And sometimes you'll get this. Like this might be like a, if you were tracking a stock or something, and maybe based on the time of the year, the value of the stock declines, and then it has this little funny shape here, and then it's a steady growth. This is how we would model that behavior. Okay? Can we do problem number